Hi everyone, I'm Yuxi Xiao and I work with Joshua Lai at California State Polytechnic University. Um, and yeah, thank you for the opportunity for me to present the research on an accessible application to foster figure skating skills using gamification. So first of all, what's the problem in current figure skating world? There's a very unclear judging criteria and rules that cause rooms for bias. On the rules judging handbook, they're literally saying give them points if they have a good takeoff or if they have good speed, good heights. But what defines good? That gives judges the room for their own interpretation, and that causes human errors or biases. And that's very unfair for the skaters who train every day and they wish to get a fair score. Um, and also, since the uncertainty and the bias caused by the rules and judges, many skaters or coaches try to use cheating techniques that might give them short-term points but long-term harm because those techniques cause them severe injuries. And that next one is there are also abusive coaching in this world because all the coaches, they want their glory, they want their skaters to perform well so that they can earn more money. So they try to let their skaters work harder by telling them, oh, you don't have a future unless you follow this crazy training routine that will cause them injuries or will make them depressed. And also they might tell them that, oh, you're so fat, you're so ugly, unless you practice more. Or so those also cause skaters severe mental problems. For example, on the picture to the bottom left, she used to be yeah, it's Yulia Lipnitskaya. She used to be like leading the skating world. However, because her coach also always tell her to that she's so fat, she actually have eating disorder and have to stop training for a few months because her body just collapsed. And lastly, there's very limited accessible training resources, especially due to geographical reasons. Some places in the world that just have no coaches or have no um, big enough ice rinks for skaters to practice. So currently, only a few countries in the world have really competitive and strong figure skating teams. So how can I possibly help this problem? So here are some main challenges and how did I approach to it. First of all, how to enhance users' skating skills off ice. Um, Ice time is very limited for our practice, so we do want to utilize time off ice to also improve and to make skaters take advantage of other trainings other than just skating on ice. So our main approach is to increase users' knowledge of how their training decisions affect their competition results. Since most skaters start training from a very young age, they are told to follow their coaches no matter what. However, as I said, those coaches might give them bad guidance, for example, using a cheated and harmful technique. So it's good for the skaters to always understand how the training decisions affect them so they can understand if the coaches is doing the right thing for them. Um, and they can also utilize this knowledge on real life training, for example, deriving a good training plan for themselves or understand oh, this mistake decreased like the points a lot, so I have to work on that. So they better visualize how they can have like the plan for improving their actual skating. And the second challenge is to standardize the rules. We have to make those adjectives like good, fast into actual data. So therefore the users can understand the rules in depth and through like playing the game so that they understand, oh, this can give me points because it might be confusing just looking at the score sheets of a competition. And I always feel meaningful to use like computer science knowledge in real life because computer science represent everything by data and it's so objective and it's fair. It has no discrimination and it's a useful, it's a very important development for the figure skating world. And lastly is an accurate representation of the competition. So there are many uncertainties in the competition since those are hard skills and most skaters can't guarantee they make it right every time, even though they perform it really well in practice. So to simulate the competition, we have to include a fluctuation in randomness when showing the training and competition results. That also trains the skaters' mental ability to, understand they might perform good in practice, but in competition, it might go off a bit to get them mentally prepared. And here's the solution. So I make a simulated skating competition, and that includes three distinct systems: the trainer, the planner, and the performer. The trainer manages the creation of the elements and keep track of each move's success rate and proficiency level. The success rate is how likely is the skater is gonna do, for example, do a jump and then land it. So they don't fail or they don't, get under rotate or make any major mistakes. And the proficiency level is how likely they will perform a move really nicely, which means they get a grade of execution more than +3. So those are definitely separate values. Some people might have really high success rate, but they mostly never do it really well, or sometimes people don't success all the time, but once they success, they do it like proficiently. And the next one is the planner. It is just in charge of creating the competition routine. So the users can just click on the element they want to put in, and then it creates a routine for them. And the performer is accessing the element in the list of routine, and it sends the data to the animator and make the animator being displayed. So the users can see their simulated skater performing the moves, and their element will also be given a score calculated using their success rate and proficiency values. So they can also see the simulating judges giving them scores. Here's the graph that basically shows how the three aspects are aligned and how they correspond to each other. So they, for the trainer, they start with the element UI displaying, showing the success rate and the proficiency. And the bias slider is allowing the users to choose their emphasis on training, whether it's more toward success rate or proficiency. And then it does, so that all in this UI includes all the different elements like jumps, high level jumps, and spins. They're all subclasses because they have different aspects. And then it passes to the planner after the trainer finished the days of training left. And it shows the selected element list, and it also includes all the element buttons so that the user can choose from. And it stores the element being chosen, and then later will be passed on to the performer. So the performer have stored each element and their GOE scores by the judges. There are many judges instead of just one, just simulating the real life. So each element will be individually scored by each judge and then go back to the GOE calculated as how the competition does it. And after that, it displays the animation of both the performance of the element and also the judges giving scores. And finally, it displays a total score table that has all the judges' scores, all the GOEs, and the total score. GOE is the grade of execution given by the judges. So first, this is the trainer part. On the right, this is the trainer's UI. So first, users select skills to train based on the skater's success rate and proficiency on each specific moves. So here's the jump table. Here are all the jumps that you can, based on those values, decide which one you should train. And they can also decide the training focus on the bottom. There's a slider, also based on the values, and the users make the decision that they feel is best for improving their skills. And also the skill being trained will improve. However, other skills will fluctuate up and down as they are not trained. Because in real life, when you spend time training other stuff, your other skills might decrease because there's a lot of fluctuation in practice, and we want to simulate that. Yeah, elements are subclass to different variations of moves, and they can be that because you can see here the triple flip and triple luz, they have the additional edge and then pre-rotation here because only these two jumps have these two aspects, so we make them subclassed. So this code segment shows the element class, which is used to represent move. Jump subclass here, and also there's spin subclass also allow them to have their own properties while still interfacing our like train fluctuate methods. This structure of data make it minimize the reputation of codes and allows modularity. And here is the train element. It acts as a controller here, and it increases the attributes of the selected element. As an element is trained, the method which is overridden on different child. Also, while training is simultaneously fluctuate each other elements to simulate how not practicing creates a general decrease in skill. So basically, these three main blocks of code helps to create that UI and also make sure the new values get updated when the user starts training and making their decisions. And here's the planner UI on the right. So users are presented with 7 different slots to plan for their routine. So they can choose totals of 7 elements. And they can select this element by just clicking on the element button. And then they will add it to the one of the boxes. And they might go back and click on the previous element they choose if they want to replace one. And to the right, here's a base value of each element, and also the total base values displayed on the button. So here's the routine class. It stores all the information relating to a routine, such as the elements player choose to perform, and then whether the element have been performed successfully. It also contains method to get total base value and override or add elements. They are very useful in displaying the UI and calculating the final score. So add element to list message is called when element is adding to a list. It's from its name. And it overrides a particular element in the routine before indexing the selector to the next empty space. And also the update all panels method, it controls the UI. So when it's called, it fetches the routine instance and extracts the element name and the base value. It then accesses each corresponding panel and then assigns the information and make sure the user can see accurate information. And then lastly, this is the performer. It stimulates the skating competition based on the routine and the training choices. And it displays the animation showing the skaters performing the move. And then afterward, there will be judges showing the judges and giving their scores. They hold up the scores. And then after all the routines are finished, all the animation and individual scores are shown. There's a total table showing all the elements performed, all the base values, and all the grade executions and individual judge scores. And so it gives the skater opportunity to see all the performance at once. So the competition coroutine is a coroutine defining the flow of the simulated competition. And it begins with playing the music and it enables the main camera. and then it enters a loop which iterates through all the elements of the list. The judge class simulated individual judges presented at a competition. It started by resetting the judges and then instantiating the animation corresponding to an element. And also calculating whether or not it is a success jump or not. And then it picks a random camera inside the ring to enable the animation. And after the animation being completed, it enables the judge camera, which shows the judge panel. And each judge contains the give score method on the right. This method also gives a fluctuating scores based on whether the move is success or whether it's considered a good performance. So after the judges finish displaying the scores, the loop cycles again, and the next element is performed. It repeats until the whole routine have been finished. Yeah, here's the demo of the three parts combining together. Yeah, I can slide on the slider to decide which more side I want to emphasize. Now I am selecting my routine. And here the competition starts. Here the judges displaying their scores. And here's the final table showing all the base values, GOE, and judges' scores. So I did do some experiments after finishing the project to see if it successfully represents what I want to do, or I should make more changes. So the first one is about determining how much our statistics, like the proficiency and success rate, are affecting the score. So first we try varying the level of proficiency and success rate using only one basic move. I choose double axle in this case to choosing one, reduce the confounded variables. And to create a routine only using this double axle and analyze the end score for each performance. I tried low proficiency with high success rate, high proficiency with low success rate, and then high and low for both. And I do 7 moves in each routine and a total of 10 routines tested. So the graph on the left shows a success rate, proficiency combined to a skating total, and to see how it affects both of the variables together. So it shows a general upward trend as expected because higher levels of both skills should lead to a higher overall score. However, there's a significant amount of fluctuation in the data, which it's kind of simulates the real world skating because there are the top skaters who might just do a poor routine sometimes because it just happens, and that's how the sports attracts a lot of people. And also the second graphs look at individual moves and scores. So individual double axel performed. Um, the proficiency and success rate are graphed as two different um, points to determine which has a more profound effect on the score. So at the higher end of the spectrum, there are more red dots above blue dots, which red dots are the success rate and the blue dots are the proficiency. So we conclude that the success rate have more effects, and it's a more important factor on the overall score, which also represents real life because if you don't success, you have deduction in points. So you lose like 3 or 4 points. But if you do it really well compared to just doing it success, it's only a 1 to 2 point difference. And our next experiment is determining the effect of proficiency on end score independent of success or failure. So on the previous experiment, we show that success rate is more important. However, we still want to make sure that the proficiency also influence the total score. So the double axel was also chosen for this experiment, and the success rate was just fixed to 100% to ensure that the results are only the product of proficiency level. And trial 1 had the proficiency level of 0, trial 2 have 10, 3 have 20, and so on. And the trial stops at 90% proficiency. And each trials will also include 7 elements tested. On the left, here's the score of each individual move, and it does show a clear upward trend as proficiency level increases. On the right is the total score of each routine, and average increase about 4 points from no proficiency to 90% proficiency. It doesn't seem very much for just 4 points. However, in competitive skating competition, 4 points can be a difference of like 3 skaters. If it will give them an advantage for getting the points. Every point matters. And I also noticed that there's a visible gap between the top graph, and since it has like high and low scores, that doesn't really lie on the line of best fit very well. That it could be because that the program is set to a threshold that's considered a good performance or not. And when a move fails or below the threshold, the simulated judges tend to give more like extreme scores. So here are some future developments of this program, which the first 3 are, which I'm working on right now. I am very close to finishing it, which is including more factors to the competition scores. Now we just have the success rate and proficiency, but we might want to add injuries, mental conditions. Those are also important factors for the actual competition scores. And I also want to include more elements, including ones in pair skating and ice dance. All the elements I was showing is for single skating, but pair skating and ice dance also faces similar problems that needs to be solved. And I also wish to create more detailed animations to show maybe a close screen to the skater's feet, and then make them see clearly what the mistakes are. And after these are all done, I also wish to connect the game results to real life training. So we may want to create a hardware also to allow the program to get trainers players real life skating data and use that skating data to determine, oh, are they doing well also in real life? If they're doing well, maybe we can give them a higher boost in success rate or proficiency when they train in the game. So it's not just playing the game, it also motivates skaters to train in the real life. And in the end, the ultimate goal is for AI scoring in real life competitions. In our game, we uses a program to give the scores. That's because all the threshold, all the data are built in to the game as well. However, in real life, the data collected might be a little bit more complex. However, we wish to reach that level that the program can also give a score based on real life skating data. Yeah, and thank you for listening to my presentation. Yeah, thank you all for giving me the opportunity, and also it's just so nice to know other programs and also just to share mine and then communicate with each other. So if you have any questions, comments, please ask me, and then I'm very happy to discuss this with you. And if you have other additional questions, you can email me. And yeah, thank you so much for the opportunity. Thank you, everyone.